Somewhere, right now, someone is standing in a grocery store aisle, glancing at a nutrition label for maybe 2 seconds before dropping something into their cart without a second thought. No fear, no hesitation, no real risk at all. But rewind that same decision back far enough, strip away every label, every regulation, every generation of accumulated knowledge standing invisibly behind that product, and you're left with a question that should genuinely unsettle you. How did the first humans to encounter an unfamiliar plant, an unfamiliar root, an unfamiliar mushroom pulled from unfamiliar soil, figure out whether eating it would feed them or kill them? There was no label, no one to ask, no internet to search, just a stranger-looking piece of food, a hungry body, and a decision that, made wrong even once, could end everything. And here's the part that should really stop you. Somebody had to be first. Somebody, at some point in every single one of the thousands of edible plants humans now rely on, had to be the very first person to eat it, not knowing what would happen next. Stay with me, because the answer to how our species figured this out is stranger, slower, and considerably more dangerous than almost anyone realizes. Let's start with something your own mouth is doing right now, without asking your permission. Humans carry roughly 25 distinct genes coding for bitter taste receptors, an unusually large number compared to most other taste categories combined. That's not a coincidence, and it's not a minor biological footnote. Researchers studying the evolution of taste perception, including work led by geneticist Paul Breslin, have pointed out that this expansive bitter detection system likely evolved specifically because a disproportionate number of naturally occurring plant toxins happen to taste bitter. Alkaloids, the class of compounds responsible for many of the most dangerous natural poisons on Earth, overwhelmingly register on the tongue as sharp, unpleasant, and immediately off-putting. Your body did not evolve to enjoy bitterness. It evolved to treat it as an alarm. Every time a piece of food tastes suddenly aggressively bitter and your whole face reflexively recoils, you are experiencing a genuinely ancient defense system, one that was quietly protecting your ancestors from poisoning long before anyone understood what a toxin even was. But taste alone was never enough, because plenty of genuinely lethal substances don't taste bitter at all. And plenty of things that taste briefly unpleasant are perfectly safe once you push past the first bite, which means early humans needed something more sophisticated than a single warning system. They needed a strategy. And the strategy researchers have documented both in wild primates and in the deep architecture of human psychology itself is almost unbearably cautious by modern standards. Psychologist Paul Rosen, whose decades of research at the University of Pennsylvania fundamentally reshaped how scientists understand disgust and food choice, coined a term for the exact bind every omnivorous species finds itself in. He called it the omnivore's paradox. To survive, an omnivore needs to try new foods constantly, because relying on a single unchanging food source is itself a survival risk if that source ever fails. But every new food is also a potential threat, an unknown substance about to be introduced directly into a body that has no immune memory of it, no prior experience to draw on. Rosen's research showed that this tension produces a very specific, very consistent behavioral pattern across omnivorous species, including us. Approach cautiously. Sample an almost comically small amount. Wait. Watch closely for any sign that something has gone wrong. This is not folklore. It's directly observable in wild primates today. Researchers studying wild chimpanzee foraging behavior have documented individuals encountering an unfamiliar plant and, rather than eating a normal portion, taking what amounts to a token taste, sometimes barely more than a lick or a single small bite, before pausing entirely and waiting, sometimes for a considerable stretch of time, before deciding whether to continue. Younger, less experienced individuals have been observed watching older group members closely during these encounters, apparently using the older animal's reaction, or lack of any negative reaction, as usable information before trying the food themselves. This is testing. It is genuinely careful, methodical, individually risky experimentation happening in the wild, without language, without written records, entirely through direct observation and first-hand consequence. Fungi made this entire problem dramatically worse, and it's worth understanding exactly why. Unlike most toxic plants, which tend to announce themselves through obvious bitterness or an unpleasant smell, many of the deadliest mushrooms on Earth taste mild, pleasant, even genuinely delicious, right up until the toxin has already been fully absorbed. The death cap, responsible for the overwhelming majority of fatal mushroom poisonings worldwide even today, is frequently described by survivors as tasting perfectly good, sometimes not producing any symptoms at all for 6 to 12 hours after it's eaten, by which point the underlying liver damage is often already well underway. This delayed, deceptive quality meant that the bitter taste alarm system evolution had spent millions of years building was, for this specific category of food, almost entirely useless. Mushroom foraging, as a result, appears to have developed into something closer to a specialized, carefully guarded body of knowledge in many traditional societies. Passed down with unusual precision from experienced foragers to designated successors, often built around detailed, highly specific identifying features, exact habitat, precise coloring, subtle differences in stem texture and gill structure, rather than the broader trial and sample approach that worked reasonably well for most other wild foods. Get it wrong with an unfamiliar plant, and in most cases your body warns you loudly and immediately. Get it wrong with the wrong mushroom, and your body might not warn you until it's already too late to matter. This is likely part of why, across widely separated cultures with no contact with one another, foraging knowledge so often became concentrated in specific individuals rather than remaining evenly distributed across an entire group. Anthropologists studying traditional ecological knowledge in hunter-gatherer and small-scale farming societies have repeatedly documented the existence of recognized plant specialists, often older individuals, frequently though not exclusively women, who carried an unusually detailed, highly specific working knowledge of which local plants were safe, which were dangerous, and precisely how dangerous ones needed to be prepared to become safe. This wasn't casual, evenly shared community knowledge. It was closer to an apprenticeship, a body of hard-won, occasionally still lethal information, deliberately concentrated in a small number of trusted people, and taught carefully, piece by piece, to the next generation. Because losing that specific knowledge, even briefly, meant the entire group would eventually have to rediscover it the same dangerous way it had been discovered the first time. Now imagine that same caution scaled up across an early human population trying to survive in an unfamiliar landscape, and you start to understand exactly how dangerous this process actually was. Because unlike a chimpanzee cautiously nibbling a single leaf, early humans were dealing with plants that could deliver consequences ranging from mild stomach upset to violent illness to death, sometimes with a significant delay between the eating and the symptom, which made the entire learning process even more treacherous. And that delay brings us to one of the strangest and most important discoveries in the entire history of behavioral science, one that explains exactly how a single bad experience could permanently rewrite an entire population's relationship with a specific food. In the 1960s, psychologist John Garcia ran a series of experiments that initially confused and then quietly revolutionized the field of learning theory. Classical conditioning, as understood at the time, required a stimulus and a consequence to occur close together in time for an association to form. But Garcia discovered something that broke that rule entirely. Rats that ate a distinctively flavored food, and then hours later experienced induced nausea from an entirely unrelated cause, developed a powerful, near-permanent aversion to that specific flavor, even though the food itself hadn't caused the sickness at all, and even though hours had passed between the eating and the symptom. This phenomenon, now known as the Garcia effect or conditioned taste aversion, turned out to be remarkably fast, often forming after a single exposure, and remarkably resistant to being unlearned. Garcia's insight was that this made perfect evolutionary sense. An animal that got sick after eating something needed to associate that illness with the taste of the food, not with the location, the time of day, or any of the dozens of other things happening in that window. Because in the wild, food poisoning genuinely does often arrive with a delay, and an animal that couldn't bridge that gap would poison itself repeatedly instead of learning from a single mistake. This is almost certainly why you right now probably have at least one food you simply cannot bring yourself to eat anymore. Something you got violently sick from once, maybe decades ago, maybe from a completely unrelated stomach bug that had nothing to do with the food itself. Your brain doesn't care about the technicality. It built a permanent warning label the very first time, using a piece of ancient machinery originally designed to keep a hungry ancestor from repeating a nearly fatal mistake with a specific root or berry. Picture an early human forager moving through unfamiliar terrain, perhaps 60 or 70,000 years ago, encountering a plant her group has never eaten before, its leaves an unusual shape, its stem carrying a faint, unfamiliar smell. She doesn't eat it. Not yet. She breaks off a small piece, presses it briefly to her lips, tastes the very edge of it, waits. Nothing happens immediately. So she takes a slightly larger taste, chews it carefully, and swallows only a small amount, then stops completely and waits again, watching her own body for any sign of trouble, for hours, sometimes into the next day. If nothing happens, she might try a bit more the following day. If she becomes nauseous, or worse, that plant is finished, permanently, in her own mind, and, crucially, in the collective memory of everyone she tells. This is not a single moment of discovery. It's a slow, repeated, genuinely dangerous negotiation between a hungry body and an unknown landscape, carried out one small, deliberate bite at a time across what was almost certainly an enormous number of individually risky trials, before any plant earned a permanent place in a group's accepted diet. And once that knowledge existed, keeping it alive across generations became just as critical as discovering it in the first place, which brings us to some of the most genuinely remarkable food processing traditions in human history. Techniques so intricate that they reveal an almost unbelievable depth of accumulated trial and error standing behind them. Consider cassava, a starchy root that today feeds hundreds of millions of people across South America, Africa, and parts of Asia. Certain varieties of cassava contain naturally occurring compounds that release cyanide when the plant tissue is damaged, at concentrations genuinely capable of causing serious illness or death if the root is eaten without proper preparation. And yet indigenous peoples in South America developed an elaborate multi-day detoxification process, involving peeling, grating, soaking, pressing, and in many traditional methods a period of controlled fermentation that reliably renders the root safe. Archaeological evidence, including specialized grater tools found at sites in what is now Colombia and Venezuela, dated to roughly 7,000 years ago, indicates this processing knowledge is remarkably old, representing generations of accumulated experimentation that somehow arrived at a genuinely effective multi-step chemical solution long before anyone understood the underlying chemistry involved. An ocean away, entirely independently, indigenous peoples across large parts of California developed an equally sophisticated solution to a completely different problem. Acorns, an abundant, calorie-dense food source across much of the region, are naturally loaded with bitter tannins that make them unpalatable and, in sufficient quantity, harmful to digest. Ethnobotanical and archaeological evidence shows that communities developed detailed leaching processes, grinding acorns into meal and then repeatedly rinsing that meal with large quantities of water over an extended period, sometimes using specially constructed sand basins built specifically for this purpose, until the bitter, harmful compounds had been thoroughly washed away. Two completely unconnected populations, separated by an entire ocean and thousands of years of independent cultural development, arrived at conceptually similar solutions, extended water-based processing, to two entirely different toxic food problems. When that kind of pattern shows up independently in unrelated parts of the world, it's rarely coincidence. It's usually evidence that the same brutal selective pressure, in this case the very real cost of getting food safety wrong, was quietly shaping human behavior everywhere at once. There's a psychological legacy of all of this that's worth pausing on, because it's still operating inside people today in a way that used to genuinely puzzle parents and pediatricians. Researchers studying childhood eating behavior have documented a well-established developmental pattern known as food neophobia, a marked, often intense reluctance to try new foods that reliably peaks somewhere around the age of 2 to 6 years old, before gradually easing as children get older. For a long time, this was treated as simply frustrating, mysterious toddler behavior, but viewed through an evolutionary lens, the timing makes striking sense. This is roughly the developmental window in which a young child in an ancestral environment would have first begun moving independently, exploring further from direct caregiver supervision, and encountering unfamiliar plants and foods without an adult immediately present to guide the decision. A built-in surge of caution around new foods, arriving at exactly the moment a small child gained the physical independence to accidentally poison themselves, isn't a flaw in modern parenting. It's an ancient safety mechanism, still quietly running its original program in a world that no longer requires it nearly as urgently. So when did humans actually finish this process? This long, dangerous, trial-and-error mapping of an entire landscape's worth of edible and inedible plants? The honest answer is that it never really finished at all. It simply slowed, layer by layer, as accumulated knowledge got passed down more reliably, first through direct observation and oral instruction, eventually through written record, and finally through the regulatory systems and packaging labels that now do this ancient work for you in about 2 seconds flat, without you ever having to taste the tiniest, most cautious sliver of anything and wait, hoping your body doesn't betray you. Sit with that for a moment. Every safe meal you've ever eaten without a second thought rests on an almost unimaginable foundation of accumulated risk, absorbed by people whose names were never recorded, who tasted a small piece of something strange, waited, and either lived to tell their group what they'd learned or didn't. Somewhere in that immense, invisible chain of trial and consequence sits the very first person who ever safely ate a wild grain, a wild tuber, a wild nut. Information that eventually made its way, unbroken, generation after generation, all the way down to whatever you had for dinner last night. Somewhere else in that same chain sits someone who guessed wrong, who tried the mushroom that looked almost exactly like the safe one, who never got the chance to warn anyone else, and whose absence was itself a kind of warning the rest of the group carried forward without ever needing words for it. That casual, unthinking 2 seconds you spend deciding whether something looks appetizing carries the full, quiet weight of everyone who came before you, the ones who got the answer right and the ones who didn't. If you made it this far, you're exactly the kind of person this channel exists for. We make videos like this one every week about the strange, unresolved edges of human evolution, about what your body still remembers that science hasn't fully explained. If that's something you want more of, hit subscribe. It costs you nothing. And it tells the algorithm that this kind of storytelling is worth keeping alive. See you in the next one.